All right, so this is my presentation on the chemistry of National Treasure. Here's the video, pull that up.
My job is to make college easier because students have a lot on their
Looks like animal skin. How old is it?
At least 200 years.
Really? Sure?
Pretty darn.
Now, if this thing's an invisible ink, how do we look at it?
Throw it in the oven.
Oh, no.
Ferrous sulfate inks can only be brought out with heat.
Yes, but this is...
It's very old. This is very old, and we can't risk compromising the map.
You need a reagent.
Dad, it's really late. Why don't you get some rest?
I'm fine.
Lemons.
You can't do that.
But it has to be done.
And someone who's trained to handle antique documents is gonna do it.
Okay.
Okay. Now, if there is a secret message, it'll probably be marked by a symbol in the upper right-hand corner.
That's right.
I'm so getting fired for this.
I told you. You need heat. See?
We need more juice.
I need more heat.
All right, that is pretty much the gist of it right there. Back to the slideshow. All right, so how accurate is the chemistry portrayed in this clip? So to briefly summarize before we dive in depth more into the chemistry, the compound they mentioned that's used to make ink, ferrous sulfate, but inks based on that compound were in fact used at the time of the Revolution. They're looking at the back of the Declaration of Independence if you haven't seen the movie. So that aspect is accurate. And if you're writing an invisible ferrous sulfate ink, you can use acids and heat to expose those inks. So that's also accurate. And I will get more into this in a second, but simply breathing on the paper ink probably is not going to work due to the activation energy required. So let's get a bit more in depth into the chemistry. So this here is the reaction between the Fe2 plus ion in the ferrous sulfate and this digallic acid ion, which is digallic acid is a component of tannins, which are found in lemons, amongst other things. So the digallic acid and the ferrous sulfate react to form this solid iron product, which shows up as the ink on the document in this case. And this overall reaction, as you can see in this reaction coordinate, is endothermic, meaning that heat must be added to make the reaction occur. When they just put the lemon juice on, the ink didn't show up, but when they breathed on it, adding some heat, the reaction did proceed for a little bit. So when they add more heat, as in using a hairdryer, and they have lemon juice on there, that will drive the reaction to occur and expose this product, which is essentially the ink shown on the paper in its visible form as opposed to its invisible form. So overall, the chemistry underlying what they're doing in this clip is pretty accurate. There are just some minor inaccurate aspects, but overall, it is pretty accurate. Thank you.